The discussion of structured proofs leads to the Fitch system. Fitch is a proof system that is particularly popular in the logic community. It's as powerful as other proof systems for propositional logic, and it's far simpler to use. Fitch has 10 rules of inference. In the version shown here, 9 of these are ordinary rules of inference. The other one, namely implication introduction, is a structured rule of inference. Negation introduction allows us to prove that a sentence is false if it leads to a contradiction. If we believe phi implies psi, and we believe that phi implies not psi, then we can derive that phi is false. Negation elimination allows us to delete double negatives. And introduction and an elimination are straightforward. If a proof contains sentences phi 1 through phi n, then we can infer their conjunction. And if we have the conjunction of phi 1 through phi n, then we can infer any of the conjuncts. Or introduction allows us to infer an arbitrary disjunction as long as at least one of the disjuncts is already in the proof. Or elimination is a little more complicated than and elimination. Since we do not know which of the disjuncts is true, we cannot just drop the operator. However, if we know that every disjunct entails some sentence, then we can infer that that sentence is true, even if we do not know which of the disjuncts is true. Implication introduction is the Fitch embodiment of more complicated reasoning that we saw earlier. If by assuming phi we can infer psi, then we can infer the sentence phi implies psi. Implication elimination is the same here as the rule we saw earlier. Biconditional introduction allows us to infer an equivalence, a biconditional, from an implication and its inverse. And biconditional elimination goes the other way, allowing us to infer two implications from a single biconditional. This exercise tests your grasp of Fitch by asking you to use the sentences P implies Q and M implies P or Q to prove M implies Q.